big noise like thunder. The rocket takes off for space. But how do we know what it's going to do? The second our rocket is out of view, with a great big noise like thunder, the rocket takes off for space. It travels so fast that it can't be seen, so we have to track it on a radar screen.
There'll be movie cameras to film the rocket flight.
There'll be TV cameras right at the launching sites. There'll be men to tell us our rocket has hurled a man-made moon that will spin and spin all around the world. With a great big noise like thunder, our rocket takes off for space. With a roar like a fire as it climbs ever high. With a great big noise like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Rocket ready for flight. Prepare for launching of satellite. Man's first step into outer space.
We're in the blockhouse, a short distance from the launching pad of the rocket. The blockhouse has concrete walls, heavy walls 10 feet thick, and a roof with reinforced concrete 27 feet thick. A few minutes ago, there was a cloud of red smoke over the blockhouse. This meant that only 20 minutes were left, and radar operators checked their electric wires just once more, as they had done many times before. Everything has been checked and rechecked so many times. Fuel, valves, electrical wiring, tracking cameras, all must be in perfect working order. In 1/2 hour from the firing, our man-made moon will be 700 miles from the launching pad and will begin to circle the Earth at an altitude of 200 miles above sea level. There's someone going to the blackboard. He writes T minus 15. That means there are just 15 seconds remaining before our rocket is fired and goes soaring into space.
10, 9, 8, 7.
Through the loudspeaker, we hear the seconds being counted off.
3, 2, 1, 0. Fire!
Is rising, slowly, balancing itself on its own exhaust blast. Now it's X plus 15 seconds, and our rocket looks like a huge silver pencil growing smaller in the sky. Ever since man looked up at the sky and saw the moon, he became curious. What was it like up there? Did people live on the moon? There were some men who actually tried to reach the moon, and many strange stories have been told about those fantastic adventures. Now, if man could build a rocket ship fast enough and strong enough to make the trip, he could travel through space to every place. Man wondered about this for years and years. We've told you something about the first space engineers, but in order to make the moon journey, first of all, we have to know how far away the moon is from the Earth.
50 round trips to California from the city of New York is the distance to the moon. We'll go there pretty soon. 7 miles a second, 7 miles a second. Our rocket ship will make the trip in 7 miles a second. 50 round trips to California.
If we travel on the road in a car that has the power of 60 miles an hour, not
7 miles a second, 7 miles a second. Our rocket ship will make the trip in 7 miles a second. 50 round trips to California. But there's one thing we should know, that with gravity around, our car can't leave the ground.
But for the purposes of space travel, our rocket trajectory would have to attain an escape velocity of 25,000 miles an hour, which is
7 miles a second, 7 miles a second.
Our rocket ship will make the trip in 7 miles a second.
Now very, very soon, we're going to the moon, and the distance we found out is somewhere almost just about 50 round trips, 50 round trips, 50 round trips to California. Put a penny in the scale and weigh yourself on the planet Earth. If you weigh 102, why this is what your weight is worth on a penny scale on the planet Earth.
Put a penny in the scale and weigh yourself on the planet Mars. You will weigh just 38 pounds. And just in case you've never heard, on the planet Mars, you will weigh 1/3.
The bigger the planet, the more you will weigh. The bigger the planet, the more you will weigh. That's the rule for you and me.
That's the law of gravity. Put a penny in the scale and weigh yourself on old Jupiter. You will weigh 252, for a scale on Jupiter is such. You will weigh just twice and a half as much.
Put a penny in the scale and weigh yourself on a station out in space. You will weigh just nothing at all, for that is what your weight is worth on a penny scale. High above the earth. Oh, the smaller the planet, the less you will weigh.
The bigger the planet, the more you will weigh.
That's the rule for you and me. That's the law of gravity. Meet Space Pilot Jones.
He's a member of the crew with a very high IQ. He's no taller than 5 feet 10.
But he can be as small as 5'2".
Meet Space Pilot Jones. He's alert and smart and quick.
Studies his arithmetic.
He is learning astronomy.
So Pilot Jones is just the man to pick.
And though his suit will not look cute, its body will look like a barrel. Its practical design will really be just fine for the best in space apparel. Meet Space Pilot Jones. He's a member of the crew
With a very high IQ.
in a uniform made for space.
He always knows exactly what to do.
Meet Space Pilot Jones.
Space Station reporting to planet Earth. We are about to attempt our first landing on the planet Mars. Space Station crew, attention please. Attention, Space Station crew.
We have been training for this flight for 2 years. Right now, we are orbiting the Earth at an altitude of 400 miles. The first expedition to Mars is about to take place. At 0 flight time, the rocket motor of our spaceship will start firing, and our ship will break out of orbit. 12 minutes later, we will move at 6 miles per second. You men know we have already made the first flight around the moon. Now, for the first time in man's history, we enter a new era in man's exploration of space and the planets. Before making our first landing on Mars, we will effect a landing on the minor planet Eros, which is 3/4 of the way to our final destination. When the 2 orbits of the planets cross, we will put our spaceship into the orbit of the planet Mars, and we will coast to its terrain by way of its own gravitational pull. It will be necessary to fire retro-rockets, as you know, in order to resist the gravity pull of Mars and to make a safe landing. As to Mars itself, we already know that it's a smaller world than our own planet Earth. Every day on Mars is about 1/2 hour longer than an Earth day. Just for review, let's ask our flight engineer what kind of weather we will find on Mars.
At night, the temperature would be about 75 degrees below zero. The reason for this is that the atmosphere is extremely thin. It does not offer enough protection to explorers from Earth. During the day, of course, the weather can be quite bearable. And in the early afternoon in the summer, the weather would be about 70 degrees above zero, which is a comfortable temperature. We also know there is water on Mars, because the polar ice caps have shown us that ice and snow have formed, but these begin to melt in the spring.
There are books by great scientists who write of canals on Mars. If there are canals, perhaps intelligent Martians have built them. Perhaps there is life on Mars. But we cannot explain why these canals, as they seem to us, have straight lines. They could be natural formations, or perhaps there are other causes. You men will learn the truth at last.